Here we go. We have a question, maximum value of an ordered triplet part 2. So before jumping into this problem, I highly suggest you to solve this part 1, then come over to this video. So we have given a zero index array. We need to return the maximum value over all triplet of indices I, j and k such that I is less than j and j is less than k. If all such triplet have a negative value, just return 0. The value of a triplet of indices I, j and k is equal to this. So we have this, and in this the maximum value can be 0, 2 and 4 indices. So 0, 2 and 4. So if we do the calculation, we got 77, which is the maximum value, right? So let's build the approach. So I have just copied the input from the example. So we have this array, and in this array the answer is dependent, the value is dependent on this thing, right? So what we want array of I as maximum as possible. And in this approach, what I will do, I will just traverse for j, right? And for k, I need maximum value as possible, right? So we want, and before that, I is less than j and j is less than k. So I is on the left side. So what I will do, I will create a prefix array of maximum, and array of and kth value is on the right side. So I will create a suffix array of maximum, right? So let me create a prefix array for this. The prefix array, first of all, this I is less than j. For j I need an iteration, right? So for current value, I will not write 12. I will not write 12. I will just write 0. Then on this index, I will not include this value. I will include the previous values. It means on our ith index, I am not including the ith value. That's it. So for this, I am not including 12. So the value is 0 as it is. Then for this, I will not include 6. This is not including I minus 1 value, but in this case I minus 1 value I will include. So I will just take the maximum between this and this value. So I got 12. I got 12. I got 12. 12. I also need a suffix array which will not include the ith value. So I will write 0 here, 7, 7, 7 and 7. Right. That's all. Then I will do a simple iteration, and in this iteration I will just iterate till this to this index, because I is less than j and j is less than k. All these indexes should be different and should be accessible. So I am just like for I am giving a position, for j I am giving a position, right? For my j value, I will just write a for loop between 1 till n minus 2. So I will do the calculation on this. This is my this is my this, and this is my this. So for this index, the value will be prefix minus current value multiply suffix. So the value will be something. So 6 multiply 7, 42, right? What is the answer? The answer is 77. Okay, so I will just take 42 and go ahead. What is the value on this index? 12 minus prefix minus current value multiply 7. So 11 multiply 7, which is 77. 77 is much bigger. So I will just update my answer, 77. What is the value on this index? It is prefix means nums of I, which is the value before, then my current value multiply the value afterwards. So it is 10 multiply 7, which is 70. What is the resultant? Resultant is 70, right? So let us just code this. It is simple. We need a left side array of n plus 1 size, and before that we also need to find n. This is till starting from 1 onwards, and left of I is maximum between left of I minus 1 and nums of I minus 1. We also need same for right side, and n will work fine. It will start from n minus 2th index. The right of I is equal to maximum value between right of I plus 1 and nums of I plus 1. We need answer. Just write a simple j loop till n minus 2 j plus plus. The answer is the maximum value between answer and left side value minus current value, which is nums of j. Then this is under braces multiply right of I, which is the maximum value. Just apply long, so it will convert into long. Let me run this and I hope it will work. And I missed semicolon. And there's a mistake. This is j loop. Okay, no worries. The variable name is j only. Then working fine. Let me submit this. And let's discuss about the time and space complexity. Yes, working fine. So the time complexity is order of n, and order of n only. So overall time complexity is order of n. What about space? Space is 2n, but we can say space is order of n. Is there any better way? Yes, we can avoid our space complexity. So let's discuss about the optimized approach. So we have given this array and we want this calculation. This is my resultant. I want the difference of nums I and nums j as maximum as possible. Multiply, if I multiply some value, it will give me as maximum value as possible. Right, so it will give me my expected result. So how do I calculate the maximum difference? For k, I can just simply use for loop. But how do we calculate the maximum difference? We need two things. First of all, this. What is this? This is my maximum value, and I want this value. I want the difference between maximum and some value as low as possible. So what I will do? I will write a simple iteration. This is for k, and using the same for loop, I will calculate the difference. Before difference, I just need maximum value. So I have this maximum, and maximum is initially 0. What is my resultant? Resultant is also is equal to 0. What is my difference? Difference, I also want maximum, right? So initially the difference is 0. Then I will write a for loop. Inside the for loop, I will do the calculation. What is the calculation? This is my difference. This is my difference. Multiply my current value. So what is the difference? Difference is 0. Multiply my current value. It will give me 0. 0 only. Then we encountered this value. So what is this value? This value is my current value. So in the next iteration, I will obviously jump to the next value. So I can use this value here. I will just increment, I will just update my maximum value. And on the same time, I will do the calculation and I will find the difference. What is the difference? Difference is maximum value which we encountered before minus the current value, because this current value is obviously will not encountered afterwards. My k will increment in the next iteration, so I can use this value. I have used this value already in the maximum, so there is no harm in using in the difference. What is the difference? Difference is maximum minus current value which is 12 minus 12, which will give me 0 only, right? So next I will encounter this value, then I will do the calculation. Difference multiply current value. Difference is 0 only, current value is 6 only, so it will give me 0 only, so my answer is 0. Then if I encountered this value, my maximum value is before that, which is my nums of I, which is before that, so I can use the current value as my nums of j, and I will store the maximum value minus current value difference, so it will give me difference as 6, right? In the next iteration, if I encountered this value, I know my difference is as maximum as possible. So difference, what is my answer? Answer is difference multiply current value, which is nums of k, my loop a variable name k. So this is the difference, which is k only, right? And this is my current value. Difference is 6 multiply current value, it will give me value as 6, which is valid, which is correct till this index, right? Then if I encountered this index, and in our next iteration k will increment obviously, so I can use the current value to find my difference. I can use as my j. So this is my maximum value, this is my j. What is maximum? 12 minus 1, which will give me 11, so the difference is 11, right? In our next iteration I will encounter this value, and what will I do? I will calculate this. This is difference multiply current value. Difference is 11 multiply current value is 22, which is much bigger, so my answer is 22. For now I will try to figure out the difference, which is maximum minus current value. It will give me 10, but my difference is much bigger. I will not update my difference. In our next iteration I will encounter this value, and I will try to calculate the resultant, which is the difference multiply current value. What is the difference? Difference multiply current value, which is 11 multiply 7, which is 77, which is valid till now. Then I will try to figure out the difference, right? So which is maximum minus current value, which will give me 5, but my difference is already much bigger, and this is the answer. We don't have any more values, so this is my resultant. Let's try to do the same thing for this test case. Okay, so we have first of all answer as 0, we have difference as 0, and I will write answer here, and I have maximum as 0. First I encountered this value, and I will calculate difference multiply current value, which is 1 multiply, which is difference is 0 multiply 1, which will give me 0 only. Then I will try to add this value here, or the difference is 0, right? Difference is 0. Next I encountered this value, and in this I will try to figure out the calculation, so which is difference multiply current value 0 multiply 10, which is 10 only. Then in this I will do my calculation. What is the calculation? Calculation is the maximum value, means nums of I multiply nums of j. I want this value is maximum as possible. In this specifically I want nums of I as maximum as possible, so I will just include 10 here. What is the difference? Difference is 10 only. In our next iteration I encountered this value, and in this it will be difference multiply current value, which is 0 multiply 3, which will give me 3 only. Then I will try to figure out the difference. This is my nums of I, which is as maximum as possible. This is my nums of j, and nums of I minus nums of j. Nums of j is my difference. Is nums of I my maximum value? Right. 10 minus current value, which is 7. So my difference will become 7. In this what I will do? I will try to figure out the difference multiply current value, 7 multiply 4, which is 28. So in this index I will get 28. And is my difference, will my difference update? No. Next, will my maximum value update? No. Next I encountered this value, and in this value what will be my answer? The resultant is difference multiply current value, 7 multiply 19, which is uh, 63 plus 70, which is 133, I think. Yes, 133. So my answer will become 133. And in this spot, will my maximum value update? Yes. Will my difference update? Yes. It will become 0 only. What is my difference? Which is maximum minus current value, which is 0 only. Right? So that's how this approach will work. Let's code this. We have maximum, we have difference, and we also need to, I think there's no need to calculate n, but we need answer. And we have this for loop for k. So yeah, this for loop for k. We need to figure out the answer. The answer is the maximum value between answer and difference multiply current value. What is my maximum? Maximum is already maximum value or my current value. What is my difference? Difference is maximum value minus current value, as maximum as possible, and just return the resultant. Let's submit this, and I hope it will work. Yes, working fine. Let's discuss about the time and space complexity. The time complexity for this code is order of n. Space in this case is constant. So I have optimized the space complexity. This is the most optimized code. I will provide both the solution in the description box. Thank you all for watching this video.